What is the entropy of mixing of the red and black checkers on an ordinary checkerboard? Assuming an ideal solution, what is the free energy of mixing? After polymerizing the checkers, what is the new entropy and free energy of mixing of the blend? There are 64 squares in a checkerboard and 12 red checkers and 12 black checkers. The red and black checkers are equivalent, so they can be assumed as 24 checkers. So we need to mix 24 checkers in 64 squares. If n0 is equal to n1 plus n2 is 64, which is the total number of squares, and n2 is equal to number of checkers, which is 24, then the number of arrangements of 24 checkers in 64 squares is equal to n0 factorial over n1 factorial times n2 factorial, which is 64 factorial over 24 factorial times 64 minus 24 factorial. Applying Sperling's approximation, ln n factorial is equal to n ln n minus n. Entropy of mixing will be K is Boltzmann constant, n1 plus n2 ln of n1 plus n2 minus n1 ln n1 minus n2 ln n2. So plugging in the values, that would be K times 64 ln 64 minus 24 ln 24 minus 40 ln 40, which is 64 times 4.16 minus 24 times 3.18 minus 40 times 3.69. So we get 42.32 K joules, where K is Boltzmann's constant. Now delta G equals delta H minus T delta S. Since no heat is absorbed or released, delta H is 0, as in the case of ideal solutions. So delta G equals negative T delta S. At room temperature, T equals 298 Kelvin. So delta G equals negative 298 times 42.32 K, which is negative 1.3 times 10 to the power 4 K joules. Now part 2. After polymerizing the checkers, so for mixing, after polymerizing the checkers, delta Sm equals negative K N1 ln V1 plus N2 ln V2, where V1 and V2 are volume fractions of the solvent, which is the checker squares, and solute, which is the checker polymers. Assuming there are two polymer chains of N2 will be equal to 2. So delta Sm equals negative K times 64 ln 40 over 64 plus 2 for two polymer chains ln 24 over 64. So 24 because the polymer chains still occupy 24 squares, 2 because there are two polymer chains, 40 is 64 minus 24, so there are 40 checker squares available out of the 64. Delta G is delta H minus T delta S. Again, assuming no heat loss or gain, delta H equals 0, or we could assume that T is the Florida temperature at 298 Kelvin, then delta H would be 0. So delta G equals negative T delta S, which is negative 298 times 32.1 K, negative 9.6 times 10 cube K joules. So if we compare for mixing 24 checkers on the board, the entropy of mixing delta Sm was 42.3 times Boltzmann constant joules, and delta G was negative 13000 times the Boltzmann constant times joules. For mixing two polymer chains formed from the checkers on the checkerboard. The, the entropy of mixing is 32.1 times the Boltzmann constant joules, and the free energy of mixing is negative 9600 times the Boltzmann constant times joules. So the entropy of mixing the polymer chains is less than the entropy of mixing the free checkers. The free energy of mixing the polymer chains is less negative than the free energy of mixing the checkers.